owing to its high-level recognition from long history. This marks certification scheme is widely recognized in Japan as a highly reliable certification scheme. Next slide, please. Uh, to begin with, let me briefly explain Industrial Standardization Act, which established this marks certification scheme. This act provides the legal framework, the establishment of this, the operation of this mark certification scheme, and general system. As you may know, these are Japanese national standards that define the quality of products and services. These are established in accordance with the procedure stipulated in Chapter 3 of the Act. Uh, Based on WTO-TBT agreement, these are established or reviewed with a view to ensuring alignment with international standards. Next, this mark certification scheme. Sorry, back to slide. Sorry. Uh, this mark certification scheme is a voluntary certification scheme that applies to this product standards based on Chapter 5 of the Act. The detail of this mark certification scheme will be explained in a later slide. Finally, general system is a voluntary testing laboratory registration system that applies to this method standards and this product standard, which cover testing methods based on Chapter 6 of the Act. The registration criteria of general system is ISO IC 1725, which is an international standard for testing laboratories. Testing laboratories are authorized to issue test certificates affixed with general logo, and these test certificates can be used in product testing under this mark certification scheme. Next slide, please. Now, let me move on to the details of this mark certification scheme. The figure illustrates the relationship among the government, the certification bodies, and the business operator. First, I would like to explain the relationship between the government and certification bodies. Based on the application submitted by certification bodies, the government conducts the examination to determine whether or not the applicant meets the accreditation criteria, including ISO IC 7065, which is an international standard for product certification bodies. In practice, this examination, including an on-site audit of the certification body's office. In addition to confirm the certification body's audit competence, the government conducts witness assessment by observing actual certification audit carried out by the certification bodies. As a result of the examination, the government grants the accreditation for certification body if it conforms to all the accreditation criteria. The expiration date of the accreditation is stipulated by the Act as 4 years. Therefore, the examination for renewal of accreditation is conducted every 4 years. Through these renewal assessment, the government continuously verifies that the certification body maintains the necessary competence for certification audit. Next slide, please. The registration type of certification bodies is broadly divided into 3 categories. First is mineral and industrial products or their processing technology. Second is electronic or magnetic records. And third, last is services. This table summarizes the registration type for mineral and industrial product or processing technology. These registration type include technical fields such as civil engineering and architectures, chemical engineering, and others. As for electronic or magnetic records and services, each currently consists of a single registration type. At present, there is no certification bodies that certify services. Uh, as a majority of certification under this mark certification scheme is mineral and industrial or their processing. So, today's presentation will focus on this category. Please back to slide, please. Back to price. Thank you. Next, I'd like to explain the procedure between the certification body and business operator. The certification body conduct an examination based on an application submitted by a business operator. This examination consists of two main components. First is quality management system audit. Second is the product testing. In the quality control system audit, the certification body confirms whether manufacturers and inspections at business operator are carried out in accordance with this. Under this mark certification scheme, it's particularly important that the quality management system enables the continuously and consistent supply of products that comply with this. Please turn to 7th page, please. 7th page. Next page. Next
Can you
page,
move on?
please.
7 here. No, this is 5.
7th page.
6, 7.
Sorry. Uh, oh, thank you. Thank you. Uh, I'd like to explain the method of the quality management system assessment. In this assessment, it confirms that internal standards are developed in accordance with this, and that the quality management system assessment is implemented based on these internal standards. These internal standards are required to include regarding inspection, storage, raw materials, process, control, etc. With regard to quality management system for mineral or industrial product or their processing technology, it's also acceptable to establish the quality management system based on this Q9001. And this Q9001 is identical to ISO 9001. In the case of electronic or magnetic records and services, quality management systems are required to be established in accordance with this Q9001. Furthermore, the assessment methods are conducted in accordance with general guidance on third-party certification system. This is this Q1001 and guidance on the third-party certification system by field and guidance on third-party certification system by applicabilities. These ensure consistency in the assessment method across all certification bodies. Next slide, please. Okay. In addition, as a part of the quality management system assessment, business operators are required to appoint a quality control manager who is responsible for promoting international standardization and quality management in accordance with the internal standards. Quality control manager is assigned a total of 9 defined authorities. Among these, two authorities are particularly important in preventing the distribution of non-conforming products. First is approval that a certified product conforms to applicable Gs. And second is approval of shipment of certified product from the factory. First, with regard to the approval that certified product conforms to applicable Gs, all required inspections must be carried out in accordance with internal standard, and the result must be reviewed and approved by quality management manager is necessary. With regard to approval of shipment for certified product, quality management manager is required to take responsibility for ensuring that non-conforming products are not shipped. Therefore, the role of the quality control manager is important in preventing manufacture and sales of products that do not meet this standard, despite displaying this mark. Furthermore, qualification requirements are established for quality control manager. Specifically, the individual is required to have knowledge and practical experience related to the manufacturing mineral or industrial product or processing technology, as well as expertise in standardization and quality management. Expertise in standardization and quality management may be demonstrated by completion the course of quality management at university, technical college, etc., or through completion of the standardization and management course provided by training institution. Sorry, please back to 3 page. Uh, thank, uh, uh, Thank you. ありがとう. Thank you. Next, I'd like to explain product testing, which constitute the other key pillars of the examination for certification. Products are sampled and tested for conformity in accordance with the applicable Gs. Testing is required to conform to the relevant ISO IC 7025. There are several approaches to product testing. For example, testing conducted at the certification bodies, another the use of the certificates issued by a third-party testing laboratory, and another testing conducted at the applicant's testing facility by auditors or by the applicant and the witness of the certification bodies. And when test certificate issued by a third-party testing laboratory are used, test certificate affixed with general logo issued by general laboratory may be utilized. Such test certificate may be used as evidence of product testing that meets the requirements of ISO IC 7025. If the third-party testing laboratory is not registered under the general system, the certification body is required to evaluate whether the laboratory meets the requirements of ISO IC 7025. If the business operator successfully pass both the quality management audit and the product testing, the certification body grants certification. In addition, after the initial certification, the business operator is required to undergo surveillance at least once every 3 years in accordance with ministry ordinance. Finally, compliance with the certification guidance and other requirements, the business operator is permitted to affix this mark to their product. Uh, Please turn to 7 page. Uh, 7 page. Sorry, next page, please. Next page, please. Sorry. So sorry, back to the page. Back to page. Back, please. Back, please. Ah, okay, thank you. This table summarizes the difference among mineral and industrial products or their processing technology, electronic or magnetic records and services in terms of certifiable entity and the assessment method and labeling. As you can see, the certifiable entity and the labeling vary depending on the categories. In addition, even for electronic or magnetic records and services, the assessment method follows the two-part structure. As for mineral or industrial product, consisting quality management system audit and testing. Okay, next slide, please. Next slide, please. Next slide, please. Thank you. Next, I would like to explain benefit of this mark. First, this mark is used to demonstrate compliance with mandatory laws such as Building Standards Act and is also utilized in public procurement for products such as concrete products and glass wool. Second, this mark enables business operator to visually demonstrate that their product meets the criteria stipulated in the relevant GIS. So this mark helps streamline intercompany transaction and serves as a reference for customer product selection. Next slide, please. This table shows a number of certification by each certification bodies. At the end of March 2025, there are 22 certification bodies with a total of 8,052 certifications. Civil engineering and architecture account for the largest number of certifications. This is due to the application of mandatory laws and public procurement. In contrast, there are only three certifications for electronic or magnetic records and none for services, meaning that the majority of certification are for mineral or industrial product or their processing. Next slide, please. This bar chart shows changes in the number of this mark certification over time. In recent years, the number of certification in Japan has been on a downward trend. The main reason for the decline is consolidation of ready-mixed concrete plants. In contrast, the number of certification overseas has been on an upward trend, especially in the category of ferrous materials and metallurgy, which include steel products. This increase is largely driven by the relocation of manufacturing sites from Japan to overseas locations, as well as new entity from abroad seeking access to the Japanese market. Next slide, please. As you can see from this chart, civil engineering and architecture account for a large proportion of certifications in Japan. In contrast, the majority of certifications overseas are in the category of ferrous materials and metallurgy. Next slide, please. Finally, I'd like to introduce activity ensuring reliability of this mark certification scheme. Under this mark certification scheme, penalty are stipulated in law for cases such as when a business operator display this mark without certification, or when a business operator failed to comply with the order to remove or delete this mark and failed to comply with suspension or withdrawal. And as an additional measure in the case of withdrawal suspension, supplementary requirements are imposed when certified business operator is subject to withdrawal or suspension of certification. In addition to penalty, the government may require reports from certification bodies and conduct on-site inspections in connection with problematic cases. If a certification body is found not to meet the accreditation criteria, its accreditation may be suspended or withdrawn. On the other hand, certification body conduct maintenance surveillance for certified business operators at least once every 3 years and may also conduct temporal surveillance as necessary. Next slide, please. The circumstance under which such temporal surveillance may be conducted are specified in certification ministry ordinance. Specifically, temporal surveillance may be conducted in the case where this revision required changes to the quality management system and so on. Next slide, please. This slide provides a summary of my presentation. Due to time constraints, I will skip the detail of the summary. This is all my presentation. Thank you very much for your attention.
Uh, Thank you very much, Mr. Onishi. Uh, Participants, could you please put your questions and any clarifications you seek on the interface that has been provided for you in the Zoom application, and we'll have a session after the third speaker to discuss your questions. Now we come to the third speaker. The third speaker is Mr. Um, Lin, Mr. Liu Guanlin. He's from the Bureau of Standards Metrology and Inspection, BSMI, from Chinese Taipei. He will share their economist experience on how the quality infrastructure supports regulatory commodity inspection. And his presentation is titled Commodity Inspection Act, Integrating Regulation and Quality Infrastructure. He is currently the chief of the BSMI in Chinese Taipei. With that, can I invite Mr. Liu Guanlin to make his presentation?
Thank you, Chair. Can you display my slide?
Uh, Mr. Liu, we are having some difficulty hearing you. Could you just check your microphone? Or?
So can you hear me now?
No, it's still a bit soft. If you could uh, put the volume louder.
How about now?
A little better, yeah.
Okay.
No? No, it's still not very audible.
Okay, so I'll change another one.
Are you adjusting your microphone? We still can't hear you.
Sorry, Mr. Liu, can you confirm whether your microphone is turned on? Mm. Yeah, we can. I can see your mouth moving, but we don't get to hear anything. I'm sorry. Yeah, still cannot hear you. Maybe maybe you can change your audio device.
How about now?
Yeah, better.
Okay, so I'll try to speak like in this way. Sorry,
All right.
sorry for the technical problem.
No worries.
Okay, so good morning, good afternoon, and good evening to everyone. My name is Guanling Liu, and I'm the section chief at the Bureau of Standards, Metrology, and Inspection, Chinese Taipei. Okay, so first I would like to thank Malaysia for giving me this opportunity to speak at this conference. And I would like to share with you BSMI's product inspection system and explain how these activities are supported by our quality infrastructure. Next slide, please. And this is the outline of my presentation today, and including an introduction of BSMI's work and our product inspection schemes and the quality infrastructure of Chinese Taipei. Next slide, please. And this is the peak appearance of our bureau. Next slide, please. And and BSMI operates under the Ministry of Economic Affairs. And BSMI stands for the Bureau of Standards, Metrology, and Inspection. And as you can see from our name, our core functions include standardization, metrology, and inspection. On the right-hand side, you can see that our first role is the development and maintenance of domestic standards. And our guiding principle is to harmonize domestic standards with international standards as much as possible. And our second role is to establish and maintain metrology system, including both legal metrology and scientific metrology. As you know, a reliable metrology system is essential to ensure accurate and consistent measuring results. Our third role is to regulate product safety, primarily for industrial and consumer products. And this includes establishing product inspection schemes as well as relevant labeling requirements. And lastly, BSMI is also responsible for supervising the accreditation body of Chinese Taipei, which is the TAF. And through these roles, it is clear that BSMI's work focuses on the key elements of quality infrastructure. And we are committed to continuously strengthening our quality infrastructure in order to better align with international development and meet the needs of our stakeholders. Next slide, please. Okay, so next I would like to introduce BSMI's product inspection schemes and their relationship with the quality infrastructure. So first, I would like to talk about the legal framework of our product inspection schemes. The highest level regulation governing product inspection is the Commodity Inspection Act. And Article 5 of the Commodity Inspection Act specifies that commodity inspection shall be conducted under four schemes, which are batch-by-batch inspection, monitoring inspection, registration of product certification, and declaration of conformity. And BSMI would select the appropriate inspection scheme based on the characteristics of the product and the associated risk levels. More detailed descriptions of each inspection scheme can be found in different chapters of the Commodity Inspection Act and related subsidiary regulations. And next slide, please. And this slide shows the conformity assessment procedures for the four product inspection schemes. And monitoring inspection is grouped together with the batch-by-batch inspection, and because they are quite similar. And for both schemes, the application must be submitted for each batch when the product is imported or released from the from the production site. In batch-by-batch inspection, every batch is inspected, whereas in monitoring inspection, inspections are conducted on randomly selected batches. And for product certification registration, applications should be submitted during the product design or manufacturing phase. The relevant conformity assessment procedures include type testing, declaration of conformity to type, quality management certification, and factory inspection. The last one is the declaration of conformity, which requires testing of product samples, and the business operator must sign the declaration of conformity before placing their product on the market. So in order to implement these inspection schemes, different types of conformity assessment bodies are designated, including testing laboratories, factory inspection bodies, and certification bodies. And next slide, please. The requirements for the designation of conformity assessment bodies are defined in specific regulations. And for testing laboratories, factory inspection bodies, and quality management system certification bodies, and the product certification bodies, they must be accredited by Chinese Taipei's National Accreditation Body, which is TAF, to ensure their technical competence. However, for quality management system certification, since ISO 9001 is a widely recognized and mature system, the accreditation from other accreditation body is also accepted, provided they are signatories to the International Accreditation Forum Multilateral Recognition Arrangement or Asia Pacific Accreditation Cooperation Mutual Recognition Arrangement. For other types of conformity assessment body, a bilateral mutual recognition agreement is required to accept results from foreign testing laboratories, factory inspection bodies, or product certification bodies. Okay, next slide, please. And the accreditation standards applicable to the aforementioned four types of conformity assessment bodies are ISO 17021 for testing laboratories and ISO 17065 for product certification body and ISO 17021 for management system certification body and ISO 17020 for factory inspection bodies. And I believe these standards are widely recognized and generally accepted at the international level. And business operators in Chinese Taipei can engage such accredited conformity assessment bodies to provide relevant services in accordance with applicable regulations. And next slide, please. And regarding the metrology system, BSMI also utilize our national accreditation body's accreditation for the designation of measuring instrument testing laboratories, and verification bodies in accordance with the requirements specified in the relevant regulations. And next slide, please. Okay, although I think the fundamental elements of a quality infrastructure are generally similar across APEC economies, but it is important to note that the quality infrastructure is a dynamic system which continuously evolves to meet emerging needs and aligned with new policy. And here I want to show you an example of how the QI has developed in Chinese Taipei. Okay, so as we all know that promoting electric vehicle is critical for achieving net zero emissions. And reliable electric vehicle supply equipment, the EVSE, serves as essential infrastructure to enable this goal. And back in 2020, BSMI took proactive steps to lay the groundwork for this initiative. We began by gathering international standards to develop domestic standards and requested our accreditation body to establish a relevant accreditation program. In addition, we promoted the development of testing facilities to build local capacity and organize numerous seminars to engage and consult with stakeholders. And building on these efforts, in 2023, BSMI launched a voluntary product certification program for EVSE safety. The program encouraged manufacturers to ensure their product comply with relevant standards. And the voluntarily certified EVSEs are proven safe to connect to the grid and ensure the safe use for consumers, offering a strong incentive for manufacturers to participate in the voluntary certification program. And in addition to safety, the public raised concerns about the metering accuracy of commercial EVSE, which charge users based on electricity consumption. And to address these concerns, BSMI required that all EVSEs intended for public use to undergo verification before being put into operation, ensuring accurate and fair billing. And since electricity meters are already subject to mandatory verification, and this decision was well received by the industry as a logical extension of existing practices. And in December 2024, we took another significant step by announcing that all EVSEs will be subject to mandatory inspection and starting July 1st this year. And the inspection requirements cover safety, electromagnetic compatibility, and cybersecurity. And this announcement also received support from stakeholders. And this journey not only highlights the evolution of Chinese Taipei's quality infrastructure, but also showcases the continuous efforts of BSMI and our accreditation body to enhance the system and meeting emerging needs while supporting innovation and trade. Next slide, please. Next one, please. So at last, I would like to use a diagram to summarize the quality infrastructure of Chinese Taipei and highlighting its three key components: standards, metrology, and accreditation. With respect to standard, BSMI is committed to harmonizing domestic standards with international standards. At present, the harmonization rate has reached 99%, ensuring that BSMI's standards are aligned with international practices and effectively reducing unnecessary technical barriers to trade. In terms of metrology, we also actively participate in major international organizations, such as International Committee of Weights and Measures and the International Bureau of Weights and Measures. And we have established a comprehensive metrological traceability system and provide a wide range of calibration and verification services to support domestic industries and other stakeholders. And regarding accreditation, BSMI works closely with Chinese Taipei's accreditation body to continuously strengthen these fundamental components of the quality infrastructure. For example, in the next section, our accreditation body, the TAF, will introduce its new accreditation program for artificial intelligence. And our accreditation body also actively participates in international accreditation organization to ensure international connectivity and recognition. And through the coordinated operation of standards, metrology, and accreditation, Chinese Taipei's quality infrastructure ensures the technical competence and reliability of conformity assessment bodies. A strong and well-functioning quality infrastructure provides a solid technical basis for other regulators in Chinese Taipei to achieve their policy objectives in a transparent and science-based manner. Another competent authority also rely on the same quality infrastructure when developing their technical regulations, allowing their regulatory needs to be addressed in a cost-effective and efficient way. And moreover, the quality infrastructure supports regulatory cooperation and mutual confidence among APEC economies, which facilitates the alignment of regulatory approaches and contributes to reducing unnecessary technical barriers to trade. By strengthening quality infrastructure, economies can enhance their regulatory capacity, support innovation and sustainable growth, and advance APEC's goal of trade facilitation, economic integration, and inclusive development. At the same time, we can also safeguarding the public safety and consumer interests. Next slide, please. Okay, and this concludes my presentation. Thanks for your attention. Thank you. Back to you, Chair.
Thank you very much, Mr. Liu, for that very interesting presentation. And again, I remind participants, if they have questions or comments, please share them on the Q&A in your application. This brings us to the end of the presentations. So we'll move on to the Q&A question and answer for this third session. I think we will go in order. We have some questions already on the chat, on the Q&A, and I think we'll start with the questions for Ms. Wang. I think there's some questions for her.
Yes, Chair.
Can you see these questions? Or
Yes, I've seen these questions, and I believe we have answered most of them in the chat box. And there is still one remaining on doubt ways. It's from it's for the technique. It's regarded to the industrial standards. So I may answer this one directly. Is it okay?
yes, you said you have answered them. Are your answers posted in the chat, or because I cannot see them?
We answer most of them
I
in
see.
the chat box, but except this one, because this one is rather complicated. I think I better answer them directly. Okay. So for this question, in addition to technical compliance, ensuring that the industrial standards consistently meet or exceed environmental safety regulations, we also have some other measures. This requires a proactive and integrated approach. For example, we have a holistic regulatory monitoring. We establish a dedicated team or process to continually monitor updates in environmental safety regulation at local, economy-wide, and international levels. This includes tracking not only current laws but also proposed changes and emerging trends. And we regularly conduct risk-based assessments um, that go beyond the checklist compliance. We evaluate the potential impacts on ecosystem, water resources, air quality, and community health, and integrating the findings into operational standards. And also, we encourage stakeholders engagement. We encourage actively engage with regulators, environmental experts, community representatives, and industry peers. And we hold collaborative dialogue to help them anticipate regulatory shifts and align standards with broader environmental goals. And from the perspective of sustainability, we also embed sustainability principles into core industrial standards, such as resource efficiency, waste minimization, and circular economy practices to exceed baseline regulation requirements. And also, we implement ongoing training programs to ensure all employees understand the importance of environmental safety and foster a culture where environmental responsibility is seen as integral to operational excellence. Also, we encourage the technology and innovation adoption, and we conduct third-party audits and certification to ensure that the industrial standards are implemented in compliance with the safety and environmental requirements. So that's basically my answer to this question.
For that comprehensive explanation. I think there's another question here on may I ask, I think this is from Sirapat Pudi Sompan. May I ask, in China, which authority is responsible for certification and market surveillance? Is this managed by the central authority or by local government? And then are these bodies under SAMR, similar to the role of SAC in standardization?
Thank you, Chair. Thank you for the question. I think I haven't give you a very overall about the responsibility of SAMR, but generally, we know the quality infrastructure includes the elements like metrology, standardization, certification, accreditation, and all these related elements. The overall management and supervision are actually falls under the responsibilities of SAMR. So SAMR is the governmental department at the economy-wide level to oversee and supervise all these related activities. And so it is a centralized hierarchy with the the responsibilities are also rested to some local departments.
Okay, thank you for that. In fact, I have two clarifications to seek from your presentation.
Okay.
Perhaps you can oblige to answer that. One was that in your slide, one of the slides, you showed that you have mandatory standards and another category, local standards. I would like to check with you if these local standards are also mandatory or are they in a voluntary category? That's one question. Secondly, you in your explanation of voluntary and mandatory standards, you said that the voluntary standards must at least meet the requirements of mandatory standards. Yeah, they should be higher than mandatory standards. So, is it common to have voluntary standards and mandatory standards with the same scopes, with higher requirements in the voluntary standard? Is that part of the practice that you have?
Okay, Chair, thank you for your question. As you can see, China's standard system operates across 5 levels to encourage innovation and to meet the market needs. And for the local standards, actually they are promulgated by the local departments. As you know, China is a vast country, and in different provinces and regions, they have different customers, and they have different and we also have different industries. So based on this, the local governments will also promulgate and to enact some local standards. And local standards are recommended by the local government, but they are not mandatory. All the mandatory standards, actually they are on the economy-wide level. Yes, and this is my this is the first question. And for the second one, actually we don't encourage all the engagements to develop as many standards as possible. But as there are different needs for different participants, so sometimes they may need to develop standards and also to meet the innovation pace. So they make some voluntary standards, but the scope is limited. For example, like association standards, they are made by the some relevant societies, and they are specifically targeted to one kind of industry, and they encourage maybe the leading enterprises of this community to implement such kind of voluntary standards, but it's not mandatory, as well as in enterprise standards as well. So the bottom line is that all the stakeholders, all the market players, you have to obey the relevant national mandatory standards on an economy-wide level, but we don't require you to implement these voluntary standards. But if you do develop such standards, we also encourage you to do that, because as the society evolve, and also we need to encourage innovation, to encourage technology development, so you can make an advanced voluntary standard, but it is not widely adopted.
Okay, thank you very much for that comprehensive explanation. I think it makes things rather much clearer.
Thank you.
Now, if there are no other questions for Ms. Wang, can I move on to questions for Mr. Onishi?
Okay, no problem. Thank you, Chair. Okay.
Mr. Onishi, I think, can you look at the questions and...
Okay, I'll answer the question.
Okay,
Okay,
thank you.
first question, just a moment. First question is, just a moment, sorry. Okay, first question is, what was the product covered under the GSMARC certification? Okay, GSMARC intended on industrial product. Just industrial product. Sorry, I'm okay. Okay, sorry. Okay. First question, I'll answer. GSMARC applies to industrial products. Industrial products are broadly included, for example, textile and electronic device, and so on. So among these, it covers product standard, which cover a broad range of the item. broad range item. Okay. Uh, okay. Next question is, are there any sector not covered this mark certification? Uh, this mark are intended for industrial product. Industrial product, therefore, management system is not covered under this mark certification. For example, this Q9001 is not covered under this mark certification scheme. This Q9001 applicable to ISO 9001. Okay. Third question, is there any other mark covering those sector not? Okay. Mm, okay, this mark is a voluntary mark. Therefore, if it is covered by this standard, this area, sorry, this cover area, sorry, this covered by other mark area also include if there are these are exist. So there is no program with displaying this mark with other mark on product. Okay. Next question. Next question. In the this mark system from Japan, which organization is responsible for accreditation the certification body? Okay. In generally, certification body are assessed by government staff directly. Okay. Okay. Next question is why not services are certified so far under GSMARC certification system? GSMARC is a voluntary certification scheme. There is no need from a business operator get a certification at the moment. So I hope to answer the question. That's all.
There was one previous question that was addressed both to uh, the speak, the first and the speaker from China, and also to you. I think the question is on beyond technical conformity, how do Chinese and Japanese industrial standards ensure compliance with environmental and safety regulations rather than treating them as secondary or external obligations? Is there some interface between environmental um regulations with the GSMARC, or they are kept completely separate? I think that's basically the question.
I'm sorry, I don't have a sufficient experience with regulatory coordination in other field, conformity assessment. Therefore, sorry, I cannot answer this question. Sorry.
Okay, we note that.
Mm.
Um, yeah, I think we would like to really seek some clarification because our understanding from your presentation that in some circumstances the GSMARC is mandatory. Are we correct to assume that? But it can be voluntary, but in some situations the GSMARC becomes mandatory.
No. This mark certification scheme is mandatory. No. Voluntary certification scheme. Okay. In some case, mandatory law, for example, mandatory law use the this mark certifications. Use the this mark.
Okay.
Okay.
So it's indirect, yeah, but basically it's operated as a voluntary system.
Yeah, yes, basically a voluntary certification scheme. Okay.
Okay. Okay, thank you for that. I think that takes us to the end of the questions. Now, would like to ask Mr. Liu from BSMI if you could address some of the questions.
Okay, no problem. I think I got two questions. The first one is how is the relationship between BSMI and TAF? Does TAF report to BSMI? So first, TAF, the national accreditation body in Chinese Taipei, is a private foundation. It's a private organization, and BSMI supervise TAF. And our management team is also the board members of the TAF to ensure the close cooperation between TAF and BSMI, and also to ensure that our policy goal can be implemented smoothly. So I think that's a quick answer to the first question. And the second question is there a formal platform for Chinese Taipei's QI bodies to provide QI services, advices to policymakers and regulators? And honestly, there is no formal platform for the QI promotion. But the BSMI was established in 1999 and has served as the core of Chinese Taipei's quality infrastructure for over 2 decades. And in this sense, other authorities are very familiar with our BSMI's function. So, with respect to regarding our experience in regulatory cooperation and coordination, and I think the first key element is standards development. So when establishing domestic standards, we will always invite relevant government agencies to participate in our technical committees. And this enables other authorities to develop standards that meet their needs and allow them to use our standard in their technical regulation and thereby ensuring regulatory consistency and coherence. And I think the effective regulatory coordination relies on close communication among governmental agencies. And at present, the horizontal coordination among agencies in Chinese Taipei functions smoothly, and which in turn strengthens the overall effectiveness of our quality infrastructure. And that's my answer. Thank you.
Okay, thank you for that explanation. I think with this, we come to the end of this theme 3, and I'd like to pass you on to my colleague, Mr. Parama Subramaniam, who will introduce theme 4 and start with the presentations. Or do you want to take a picture first? Oh, hold on, I've just got a note that they want to take a picture of all the presenters. Could you hold on for a minute while I pass you on to the MC?
Speakers for both teams 3 and 4. So we would like to request for all the speakers who are in the presenters room to open up their cameras for all, for the theme 3 and also for the theme 4, which is after this session. Please kindly open your cameras. Alright. Just give us a moment. So our tech team is currently working on to put everyone's window within one frame. So I hope you can be patient. All right. So on the count, I think we are ready. On the count, sorry, sorry, we have to see it in the screen too. Okay. All right. On the count of three. Three, two, one. Okay, one more. On the count of three. One, two, three. Okay, so we are done with our photo session for today. So we might proceed with the following theme. So I hand it back over to Mr. Raj to continue.
Yeah. In fact, Mr. Parama Subramani, my colleague, will introduce Team 4.
Good morning, good afternoon, and good evening, depending on where you are. We are now entering the final session of this conference, session 4, with the theme New and Emerging Technologies. The final session will be on QI infrastructure and its response to new and emerging technologies, which include digital technologies such as AI, alternative technologies, alternative energy, biotechnologies, quantum technology, and smart manufacturing. So this session will focus on the QI infrastructure needed to support the development and implementation of new and emerging technologies in terms of building trust, facilitating market access, ensuring safety and interoperability, and fostering a common framework for innovation and regulation. In this session, we will have two speakers. Um, the first will be by Mr. Zheng Mingrui from China, and the second will be from Mr. Louis Kao Su Huan from Chinese Taipei. The first presentation by Mr. Zheng will titled "The Urge for Standardization in Quantum Technology." Mr. Zheng is from the Jinan Institute of Quantum Technology in China. Mr. Zheng, he holds a bachelor's degree in mathematical physics and a master's degree in quantum physics. He has been an engineer at the Jinan Institute of Quantum Technology for more than 5 years, specializing in research and standardization of quantum information technologies. Mr. Zheng has experience in quantum information standardization work both at the national and international levels. He serves as the secretary of the National Technical Committee of SAC, the Standardization Administration of China. This technical committee is on quantum technology and metrology. He is also Secretary General and contact person of the National Mirror Committee of China to the IEC-ISO Joint Technical Committee 3, which is the technical committee responsible for standardization in the field of quantum technologies. It is now my pleasure to invite Mr. Zheng to make his presentation. Again, as I said, he will be speaking on the topic, the urge for standardization in quantum technologies. And I think from his background and experience, Mr. Zheng is eminently qualified to speak on this subject. Mr. Zheng, the floor is yours.
Thank you for our host. Distinguished guests, ladies and gentlemen, good morning and good afternoon. My name is Minrui Zheng from Jinan Institute of Quantum Technology. It's my great honor to be here today to share with you our perspectives on the urgent need for standardization in quantum technology. The title of my presentation is The Urge for Standardization in Quantum Technology. In these slides, I will show the latest development in quantum technology, understand why standardization is critical at this moment, and discuss collaboration perspectives within the IEC ISO GC3 framework, particularly under the APAC framework. I hope to provide you with a global vision of quantum standardization. Next, please. My presentation is divided into three main parts. The first, I will review the current landscape of quantum technology and examine why standardization has become an urgent necessity. Second, I'll provide an overview of ongoing standardization activities worldwide, highlighting the progress of major international organizations. Finally, we will look ahead to explore how we can enhance collaboration within ISO GDC3 framework and the IPAC initiatives. Next, please. The quantum era has officially arrived, marked by the 2022 Nobel Prize in Physics award to Alan Aspect, John Clauser, and Anton Sling. They were recognized for experiments with intangible photons, establishing the violation of bio-inadequates and pioneer quantum information science. The official announcement explicitly say that their achievements have paved the way for new technologies based on quantum information, including quantum computers, quantum networks, and quantum communications. This recognition from Nobel Committee validates the quantum technology is transitioning from theoretical curiosity to practical applications that will deeply change our whole world. Next, please. As you know, quantum information science encompasses three core domains: quantum communication, which offers unconditional, secure, rooted in quantum mechanic principles. Quantum computation and simulation promise exponentially enhanced computational capacities. Quantum metrology provides unprecedented precision in measurement. These domains are not isolated. They are synergized and converge to reshape the future of information technology, creating a complete ecosystem of quantum from basic research to commercial applications. Next, please. Then I want to talk about quantum key distribution. QKD is the cornerstone of quantum communication. The fundamental advantage of QKD is that any eavesdropping attempt inevitably disturbs the quantum state and will be detected. This ensures secure key distribution. Then combined with one-time paid encryption, it provides unhackable communication phenomena. Even with classical symmetric encryption, QKD can supply flash seed keys at rates far exceeding classical method, dramatically enhancing security. Next, please. Nowadays, China has been at the forefront of the QKD networking deployment. The Beijing-Shanghai backbone network exceed 10,000 kilometers, spanning 19 provinces, and a city network covered over 20 cities. And we operate 6 satellite ground stations interconnected with the MUSIS and QI21 quantum satellites. This large-scale development demonstrates technological maturity and provides rich practical scenarios for standardization. For example, network construction, operation, and maintenance all require unified technical specifications, precisely where standardization delivers its value. Next, please. Globally, multiple regions are active building QKD networks. Sorry, I couldn't cover all the regions. For example, the Tokyo network since 2011 and the USA quantum corridor currently in progress. and Cambridge Quantum Network from 2019, Madrid Quantum IC, and the Republic of Korea Network launched in 2022, and the European Quantum Communication Infrastructure, the EURA QCI, is underway. This independently developed network will eventually need to interoperate. This creates an urgent need for international standards to ensure compatibility, interoperability, and security across different regional systems. Next, please. Now I want to introduce, next, please. Yeah, then I want to introduce other maturity products, QRNG. Sorry, next, please. Yeah, we can find applications in numerous fields, crypt cryptography and for key generation, and Monte Carlo simulation in numeric modeling, random initialization in AI training, and many more. According to IQC Research's 2023 report, the QRNG market is expanding beyond traditional casino and military applications into mobile communication, IoT, and the automotive industry. The market is projected to reach 1.2 billion US dollars by 2028 and growing to 4.4 billion US dollar by 2032. This makes QRNG poised to become the first mass market quantum device, bridging the gap between quantum research and commercial reality. As we've seen, cutting-edge research in QKD and QRNG is highly active. Without unified standards, we face significant challenges. Device cannot interoperate, performance evaluation lack credibility, and technical trade barrier emerge. Therefore, the need for standardization is extremely urgent and will directly drive industrialization, acting as an essential bridge between research and market. Next, please. Then let's move on to the quantum computing. The development of quantum computing follows three key milestones. Milestone 1 is achieving quantum computational advantage, outperforming classical supercomputers on specific tasks. This was realized by Google Sycamore in 2019, and USTC's Jiujiang in 2020. Milestone 2 involves quantum simulators that can efficiently mimic complex quantum system, such as high temperature superconductivity. And milestone 3 is a universal and programmable quantum computation with quantum error correction. We are currently transitioning from the noisy intermediate scale quantum era towards fault-tolerant quantum computing. Next, please. As we know, quantum computing is currently transitioning from research to engineering. The priority area for standardization should include a benchmarking method for hardware and software, supply chain specification, and NISQ era use cases, and service platforms. These standards will provide users with election criteria, vendors with development guidelines, and investors with assessment frameworks. essential for the health quantum computing ecosystem. Next, please. After that, the quantum metrology and measurement. In 2018, the 26th General Conference on Weight and Measures redefined the international system of units based on quantum phenomena. The second, our most precise unit, is now defined by the fixed frequency of the cesium. This quantum-based definition achieves a precision of 10 to the power of minus 18, making measurements dependent not on physical artifacts, but on fundamental consistency of nature, which is a revolutionary moment for metrology. Next, please. Quantum precession measurement is already widely applied in positioning, navigation, aerospace, environmental monitoring, and resource exploration. Urgent international standards are needed for like time and frequency reference, optical clocks, atomic gravimeters, single photon resources, and quantum gyroscopes, quantum magnetometers, and quantum leader. These standards ensure traceability, comparability, and reliability of measurement results. Next, please. Overall, standardization is the crucial bridge connect research and industry. For academia, it unifies technical language and resolves the conflict between diversities and consistency. For industry, it lowers transformation barriers, reducing trial and error cost and collaboration risks. For capital, standardized technologies attracts more investment support. And for the ecosystem, it unifies core requirements while leaving room for additional function and innovation. Without standardization, there can be no large-scale commercialized of quantum technologies. Next, please. Let me review the. Sorry, next, please. Next, please. Next, please. Yeah, let me review the global standardization process. In 2008, ETSI established ISG QKD with 12 projects. From 2016, IEC, ISO, IEEE, ISO IEC, and ITUT launched quantum initiatives. In 2023, IEC established SAG 14, which proposed creating GTC3. In 2025, at ITU's AI for Good Summit, Professor Zhang Qiang discussed the global cooperation and enterprise participation. These events mark the transitioning from fragment exploration to coordinate quantum standard activities. Next, please. As mentioned before, in December 2023, IEC ISO GTC3 for quantum technology was officially established. The chair is from Republic of Korea, is Hansen Lee, and the secretariat is from BSI. The scope of GTC3 covers quantum information technology, quantum metrology, quantum sources, detectors, communication, and enabling technologies. Currently, we have 32 P members and 10 observing members. This structure ensures participation from all major technology nations, laying the foundation for truly international standardization cooperation. And GTC3 comprised several key bodies. Advisory group handled strategic planning, and project team developed technical reports. And the working groups focus on a specific domain. There are 9 working groups have been established, covering terminology, sensors, quantum computing, and the quantum supply chain, and benchmark, QRMG, enabling technology, and so on. This structure ensures both specialized expertise and balanced development across all quantum technology domains. Next, please. GDC3's repeat development is remarkable. By its fourth plenary in late 2025, it has established 10 active working groups, which are tackling the most urgent topics, like WG9 is for terminology, and the 10 is for sensor, 11 is for supply chain, and 12 is for benchmarking, uh, and the 13 is for QRNG, and the 16 is for quantum communication, among others. Project teams are already delivering with draft on quantum computing overview and quantum photonic vocabulary. This demonstrates GTC3's efficiency in quantum standardization. Next, please. Yeah, I'm glad to announce that the next GDC3 plenary meeting, which is the 5th, will be held in Jinan, Shandong, China, from May 25th to 28th this year. This will be a key opportunity to advance these critical documents and welcome greater global participations. Next, please. Okay, for WG10, it's for quantum sensors. Sorry, one sec. It's not just paperwork. In WG10 on quantum sensor, there's 84 experts from 15 countries developing an international standards for quantum ground meters. This is tangible progress that will directly impact industries from civil engineering to resource exploration. Next, please. In the field of quantum computing, WG11 focus on the quantum computing supply chain, led by Dr. Lin from United States, and WG12 handles quantum computing benchmarking, convened by Japanese expert Dr. Masahiro. These two working groups collaborate closely on projects, including hardware supply chain algorithm level and hardware level benchmarking. These developments are crucial for establishing fair performance evaluation systems. Next, please. In the field of quantum communication, WG13 focus on QRNG and most market-ready quantum device, led by Dr. Minghan Li from China, and the newly established WG16 covers quantum communication. Each of the WGs bring together world-leading experts, demonstrate international cooperations. Next, please. Looking forward under APAC framework, we can enhance collaboration with GTC3. First, by establishing joint working groups to address common regional needs. Second is aligning standardization roadmaps to avoid duplication and improve efficiency. The third is sharing resource pool, including testbed, datasets, and expert networks. And the last one is facilitating talent exchange, especially for young scientists and engineers. Next, please. Yeah, the multiple bodies, one quantum force. This is essence for collaboration innovation. Ladies and gentlemen, quantum technology is transitioning from labs to market, from theory to application. During this critical transformation, standardization is not just a technical necessity, but a strategic impediment. The establishment of ISO GDC3 marks a new era in global quantum standardization. As an APAC member, we have a responsibility to strengthen collaboration and jointly drive standard development, creating a solid foundation for the healthy growth and industrial scaling of quantum technologies. Let's work together to write a new chapter of cooperation in the quantum era. Thank you for your attention. Thank you for our host.
Thank you very much, Mr. Zheng, for your very comprehensive presentation on the evolution and rapid developments that have been taking place in the field of quantum technology and related applications, and for your clear identification of the need for standards in this sector. You have also uh, provided a lot of information about current ongoing work on standards development in the field of quantum technology. Thank you very much for your presentation. We will now move on to the next presentation in this session under the theme again of new and emerging technologies. The next presenter will be Mr. Louis Kao Su Huan from Chinese Taipei. Uh, Mr. Louis Cao holds a master's degree in mechanical engineering. He is currently accreditation manager at TAF, which is the Chinese Taipei accreditation body, and is responsible for managing ISO IC 17025 accreditation in the mechanical field, overseeing approximately 100 laboratories. He also serves as a TAF assessor with expertise in metallic materials testing and automotive product testing. He has professional experience in testing and quality assurance of automotive electrical components and mechanical parts. He is skilled in project management and cross-disciplinary coordination with experience in integrating mechanical, electrical, and software expertise for testing, automation, and product validation. More importantly, Mr. Cao is currently coordinating the development of the AI large language model testing laboratory accreditation program at TAF. As such, Mr. Cao is eminently qualified to speak on the topic of large language model certification for artificial intelligence. I would like to invite Mr. Cao to make his presentation.
Thank you very much. Good morning, good afternoon, good evening, depending on your time zone. I'm very honored to be invited to speak today. I'm Louis Cao, accreditation manager from TAF, representing Chinese Taipei. And today I would like to share our ongoing work on language model certification for artificial intelligence, which is not fully established yet. And to be honest, while our long-term goal is product certification, but as everyone knows, testing always comes before certification. At this moment, we're still building testing capacity. So my presentation is about how we're trying to build an evaluation and accreditation framework for for language models to fulfill our local needs in our economy. Next slide, please. Before going further, I would like to share several key definitions. First, of course, an artificial intelligence systems refers to engineer systems that generates output such as content, forecast, recommendations, or decisions for a given set of human-defined objectives. And the second one is the conformity assessment, refers to demonstration that specified requirements are fulfilled. These concepts are essential in this project because the main idea of my presentation today is not about AI performance. It is an more like an experience sharing about trying to establish a third-party evaluation and accreditation framework. So language model can be evaluated not only through developers or users self-assessment, but also through a third option, an independent third-party evaluation under an accreditation framework. Next slide, please. And as everybody know, AI system cover a wide range of technical domains. Here, I put 6 types of AI applications. I reference the Hugging Face test classification, and including natural language processing, computer vision, audio AI, reinforced learning, tabular AI, and multi-model systems. And by the way, speaking of Hugging Face, you may think it as an something like GitHub for AI and open source and widely used platform in the AI community. And at the first stage, as my topic of today's presentation, our works focus on the golden one, the natural language processing systems, specifically in language models, and more precisely in TF side. We limit the current scope to pure text-based language models, excluding multi-models and AI agents. And between all kinds of AI, why choose the language model to become the first stage? Actually, it was not chosen by TF, it was chosen by the Ministry of Digital Affairs in our economies. My understanding is that because in Chinese Taipei, an increasing number of companies are already using or trying to use language model to support their daily works. So that's why it's the goal of the first stage. Next slide, please. And there are more and more companies start to use language model, as I mentioned earlier. So the language model are increasingly deployed in both public services and industrial applications in our economy. However, language model evaluation still faces several challenges. First, most AI evaluation approaches remain at the academic or industry level and haven't yet become widely accepted standards. So AI evaluations are often conducted by developers or users themselves without a third-party conformity assessment framework, and this to the test results of language model might lack consistency and comparability, making cross-organization acceptance quite difficult. So it's because language model testing is not like AI management system certification, where the international standards have already been published, like ISO IEC 42001 and SOC 42006. And at this moment, as far as I know, there is less international testing standard for language model evaluation. Therefore, the Ministry of Digital Affairs, we call it MODA, which is the regulatory authority of this framework devoted to standardization for AI language model evaluation, specifically for traditional Chinese. And why focus on traditional Chinese? It's because in Chinese Taipei, the most common way to develop language model is to rent general foundation models from large global technology companies such as OpenAI or Google or something like that, and then using skills like fine tuning or retrieval augmented generations, like what we call RAG, to turn the general model into domain-specific models to meet users' needs. However, these foundation models are controlled and developed and trained by large global technology companies, which are typically trained on massive and multilingual data sets that are mostly non-traditional Chinese. While in actual applications, and the output of language model are primarily delivered in traditional Chinese. And next point, we try to build AI testing labs and AI certification bodies and the conforming assessment framework to enhance the credibility, the traceability, and the acceptance of language model evaluation results. To conclude, the objective of this work are focused on pure text-based language models in traditional Chinese, and we try to make the results competence, acceptance, and equivalence. Next slide, please. This slide is about challenges we face. Language models outputs characteristic is quite unique. Unlike, for instance, tension or the hardness test of the metal, it's easy to get the similar results, so the reproducibility won't be a problem. But in language model, it's not like that. Language model outputs are not deterministic and can change due to several reasons like model version updates, variance settings, such as temperature, top P, top K, frequency penalty. There's a lot of parameter would affect the results of the language model outputs, and even the system configuration changes. For instance, we change the rec. It's like change the reference books of the AI, so the result will definitely be quite different. And even whether the model is connected to the internet or not can have a significant impact on the result. So the reproducibility becomes quite challenging. Uh, it have to be able to consider and control all that parameters above and maybe more to make a test results that can be reproduced. In addition, as you can see on the right hand side, there are many properties such as safety, privacy, reliability, and so on, which all I think can be tested, but standardized testing methods are still not published. So there is really a lot of work to be done to evaluate the AI properties. Next slide, please. And in Chinese Taipei, the regulatory authority of this is the Ministry of Digital Affairs, MODA, and MODA has established the Artificial Intelligence Evaluation Center called AIEC to develop AI evaluation frameworks and assessment systems. The text of AIEC include coordination, consultation, review, and planning related to evaluation, AI evaluation frameworks and standards, as well as oversights the AI test labs and AI certification bodies. The main purpose of it is to foster AI development while supporting the appropriate and trustworthy application. And AIEC consists of steering committee and technical review panel. And the steering committee's function is to set a strategic direction, and the technical review panel is to provide technical expert to support AI evaluation methodologies. Next, please. And this slide summarizes the key milestone of the Ministry of Digital Affairs and the AIEC. They started from the late 2023. Activities have included guideline drafting, engagement with international AI companies and or companies within Chinese Taipei, and technical committee meetings. And the most important one, I think, is the last one, the launch of a trial lab operations. So there is one lab operated under trial run using a draft form of a testing standard. It's just a draft now. It's not formal published, with only 5 auto evaluation items, which I will mention later. Next, please. And here is the guideline for evaluation AI product and systems. And AIEC has issued guidelines for evaluating AI product and systems, which is only a draft now. and this is also an unofficial English translation. These guidelines are voluntary, not mandatory, and may be used as a basis for evaluating the performance of AI products and systems. Guidelines draw reference from several international frameworks, including, for example, the NIST AI Risk Management Framework and ISO 24028 and the EU AI Act, EU Ethics Guidelines for Trustworthy AI. And based on these references, the guidelines adopt a risk-based approach, defining 4 risk levels similar to EU AI Act, as well as 10 evaluation items similar to the NIST AI RMF. In addition, the guidelines address risk identification and risk management and provide recommended measures for AI governance and evaluation. And the guidelines also provide recommended measures including third-party assessment, continuous monitoring, and education and training. Next, please. And this is the testing method, the technical criteria for language model. And this is also draft for now, and it's an unofficial English translation. And this criteria is also voluntary. For the first part is for language model, and I think the second part will be computer vision, but I haven't seen it yet. And as I mentioned earlier, this in Chinese Taipei we use fine tuning or RAG models, and those models are primarily trained on global multilingual data sets, so their traditional Chinese outputs may not fully reflect local linguistic usage and social context. Therefore, these technical criteria specifically focus on traditional Chinese applications, and technical criteria include 10 test items, 5 auto evaluation items, and 5 human evaluation items. And it also defined how to construct the question bank for each evaluation item, as well as how to evaluate language model outputs. And just for clarification of these documents, guidelines, and the testing method technical criteria are currently in draft form and haven't been formally published. Next, please. I'm sorry, next, please. And here are 5 evaluation items which are designed for automated or semi-automated evaluation, including fairness, accuracy, reliability, privacy, and security. And each item's definition, I put it here for your reference. I will not go down to detail here. And the definitions is reference to international frameworks. By the way, these 5 items are also the ones that can currently be tested by the trial run labs. Next, please. Next slide, please. I'm sorry. Back to the last one. And this is human items, 5 human item evaluation items. And these include safety, explainability, resiliency, transparency, and accountability. Next, please. And let's talk about how it's going to be done. After a localized traditional Chinese question bank has been developed for each different properties, the workflow is shown below. And this picture, I got it from the draft of the guidelines. And first, we have to log into the evaluation tool and develop which is developed by the AI Evaluation Tool Development Lab. And second, we select the evaluation items, like for instance, accuracy, privacy, so on, and input the risk level. And third, we submit the evaluation request for the AI system via APIs. And fourth, validate the correctness of the AI system responses, either through automated programs or human judgment, depending on your auto test item or human test item. And finally, here the results will be shown. Next, please. And this slide illustrates the overall evaluation system framework. I will just start from the left. The Ministry of Digital Affairs has established AIEC, and AIEC coordinates AI testing lab and certification bodies. And also there is an evaluation tool development lab. And then on the right side is us, TAF. We accredited the competence of testing labs and certification bodies in accordance with this ISO IEC 17025 and ISO IEC 17065, respectively. And the first stage target is localized language models, followed by, you can see on the picture below, the second stage is computer vision systems, and the third stage is domain-specific language models, and the fourth stage is language vision model testing embedding systems. And at this moment, we're still in stage one, and stage one is currently in progress. Next slide, please. And finally, I would like to share TAF roadmap for building accreditation competence. We started from the middle of 2025, and we have recruited AI experts from academia, industry, and regulatory authorities, and to establishing working groups. And we initiated the assessor training programs. And for the ISO IC 17025 part, which covers the accreditation of testing laboratories, we have already held 5 working group meetings, and these meetings mainly focus on how to define test object codes and test item codes under the TAF accreditation scheme. In practice, when TAF opens a new accreditation field, we need these codes to clearly identify the technical scope of the lab and the competence of assessors. And these codes are also shown on the accreditation certificates. Uh, so that's why we need to define the codes. And since the test methods are still in draft version, and we can access to the draft version or use the draft version method to accreditation. Once the AIEC guidelines and the technical criteria are formally published, we will bring the standardized testing method back to the working group we have to define a clear assessment point or requirements for laboratory assessment. And our goal, just a goal, is to provide accreditation services for AI language model testing labs in 2026, and followed by accreditation of AI product certification bodies in 2027. This is the last slide. I forgot the thank you for your attention slides. However, thank you very much for your attention, and I would now like to hand the floor back to the host. Thank you.
Thank you very much, Mr. Luis Cao, for your very comprehensive presentation on what the ongoing work with regards to the framework for the testing, certification, and eventually accreditation of AI labs and also also product certification bodies. I think it's very clear that you are leading in this area, in the forefront of work that's being done in this area, and the presentation has been very interesting and enlightening to everyone. I'd like to now invite questions. I don't see any. Are there any questions from the participants? Ada? No, Ada. I can't see. I don't know why I can't see the questions. I don't see any questions for this session actually. Uh, oh, okay. I'm not seeing them. Sorry. Maybe Mr. Are the questions directed to? Yeah. If you can see the questions, Mr. Jeng and Mr. Kao, can you please respond to the questions that have been directed to you?
Yeah, I noticed that there's a question about conformity assessment in quantum technology. Actually, it's an excellent question. Conformity assessment is still too premature and underdeveloped for quantum
Okay.
technology.
Okay.
The characterization of quantum field by GTC3 is still in progress. For example, the benchmark standards for quantum computing are currently being formulated. There are no plans for conformity assessment at this stage,
Okay.
and relevant work may be carried out in more mature subfields such as quantum communication and possession measurement in the future. Thank you.
Thank you very much, Mr. Zheng. So there is nothing much that's taking place in the way of conformity assessment at this stage. It's still standards. There's very much work that's being done on standards, but conformity assessment is still some way off. Thank you very much. Are there the next question? Any questions directed to Mr. Kao? Are there? Oh, sorry. Because I'm not seeing them. I'm sorry.
Oh,
Is,
okay. I see there is a question for both speakers. How does QI give advantage to these new technologies such as quantum technology and artificial intelligence? And uh, in my presentation, for now, the test of language model mostly tested by the users or the developers of itself, and it might lack consistency or credibility, or cannot be easy to be compared to each other. So under this, under the quality infrastructure structure, I believe it might enhance the consistency of the test results, I think.
thank you.
Thank you. That's my
Okay, so basically, that the response is that having QI will help ensure. At the end of the day, I think it's about building trust and acceptance. I mean, if at the moment you have to rely on developers themselves doing their own tests, the results may not be comparable. The results may not be reliable. So having third-party quality infrastructure institutions providing services will help in building trust and acceptance. I think facilitating market access of these products and services, and also it's essentially providing a technical foundation for these products. So I think that in that sense, it's clearly I think that both speakers have clearly underlined the need for quality infrastructure services. As we mentioned, in quantum technology is still early days, standardization, it's only at the standardization stage, whereas in the case of AI products and services, we are moving forward because of increasing application of AI products and services. There is clearly a need for third-party involvement and to provide this kind of trust for people to have confidence in the products and services. So there needs to be third-party evaluation and some form of conformity assessment. Yeah. Maybe I would like to now pass the floor to my co-moderator, Mr. Rajinder Raj.
Thank you, Parama. I think today we have heard two presentations in two areas of new and emerging technologies. It's quite interesting that we can see how QI infrastructure can address new and emerging technologies at different stages of development. It became quite clear that quantum technologies are at an earlier stage where standards plays a part in supporting R&D and development of the technology itself. And that was quite clear in the various aspects and applications of quantum IT. And we see that the AI is at a more advanced stage where we go beyond standards. There are some standards there, and now we are going into conformity assessment, yeah, which is an certification and accreditation that shows that the QI infrastructure is applicable and supports the development at all the stages through the life cycle of new and emerging technologies. I think that's what we can take from these two sessions in a broad sense. With that, I think I would like to thank all the speakers and participants. As a follow-up, before I conclude, we will be compiling all the presentations and putting them in the compendium. And we will also try to capture the discussions, the questions, and the responses given. And putting them also in the compendium. And I think we have collected information of the QI infrastructure in the APEC economies, and some members have responded to our draft, and I think we'll be compiling and developing a draft, a new draft after this workshop and putting in the compendium. And we'll be giving, I think, member states, member economies, one more opportunity to have a look at the draft compendium and the draft summary of the QI infrastructure and to respond. And I think we'll work out and send notices to everyone so that we have a finally document that everyone is comfortable with. With that final statement, I'll pass you back to the Master of Ceremonies. Thank you.
Yeah, that is your closing. Yes, thank you, Mr. Raj and Mr. Parama, for gracefully and professionally handling all the panel discussions with our esteemed speakers since yesterday, as well as the questions posed by the participants. Ladies and gentlemen, it appears that we are ahead of schedule, so we have actually finally come to the end of our virtual conference on best practices of quality infrastructure in APEC economies today. On behalf of the Department of Standards Malaysia, I would like to thank all the participants for your attendance and engagement throughout this virtual conference. May all the information and knowledge conveyed by our distinguished speakers for the past 2 days have provided you with beneficial and useful insights on best practices of quality infrastructure, whether in governance, strategy, human resource development, service delivery, technical regulations, or emerging technologies. We would also like to apologize for any shortcomings that you have encountered encountered throughout this conference. And with that, my duty as the MC for this virtual conference ends now. Have a great lunch and please enjoy the rest of your day.